supported. And therefore we have a crypto abstraction where we can change the algorithms, where we can change the toolkits. Algorithms means we can also support proprietary algorithms because we can exchange toolkits. The GOST algorithms are nothing else than another word for Russian algorithms. In Russia we have GOST, in Germany we have DIN, and the Russian government enforces the use of algorithms which are specified in the GOST specification. This means if you want to introduce a PKI system in Russia, then you can only introduce cryptographic algorithms which are supported or allowed by GOST. It's not to break in, these specifications are not used to break into these algorithms, but the Russian government don't trust Western researchers, and so they specify their own cryptographics. This is really interesting because often it is exactly the same cryptography, but explicitly you can only use these algorithms as if they specified in GOST specifications. So GOST is nothing else than DIN. But we can it's implemented and it works. We can even issue certificates with OpenSSL, but with GOST keys inside. So another interesting issue are different protection classes for used keys. Usually big companies use HSMs, but for a university like my university, it's simply too expensive. So you can only use soft keys, but at soft keys you have the problem, for example, how we do M out of N passphrases. And even this is possible if you use software. But we have a very, very fine granular mapping for the security. You can even enter hard-coded passphrases in our configuration if you want it. Okay, it's not recommended, but for some test cases it makes perhaps sense to have a hard-coded CA passphrase or no passphrase. And the last thing, like I noticed, hardware security modules, because this stuff works in very different ways. You never know what they really does, but they are secure, okay? The interesting stuff is that nearly every hardware device vendor has another system how their modules work with OpenSSL. If you think, for example, engines are standard, then you can look at Luna devices from or in Sci-Fi devices. One guy simply patches the toolkit and then it works, okay? And the other guy simply put a complete shell around the OpenSSL toolkit and runs the OpenSSL toolkit in a shell box. So, okay, it's not nice, but it works. Like I mentioned, I only want to talk very short about cryptographic abstractions because it's a little bit difficult and it's not very nice to present in so short times. Another feature which was often requested was configuration inheritance. The common problem in configurations for CA systems is that we have very, very small parts in the configuration which really change. Usually you have to change some information for the private key, for the name of the CA system, but the most information, if you have a PKI introduced in your company or university organizations, are statical. The organization name usually not change, the country or the domain encoding does not change. The most institutions which you have will never change. So you never have to change the configuration for an interface or for logos or for paths in your configuration or even for databases. It's very rare that people suddenly change their database systems. If they decided for Oracle, then they use Oracle for every time. If they use Postgres, then they will use it for the next 10 years, hopefully. So you have many repetitions. The next thing is, if you create a new CA, you don't want to make mistakes. So what you are doing, you copy. You simply copy the whole stuff and you try to make minimal changes. And usually you forget something. And the final thing is, you have a basic configuration and you have only to do very small local additions. This is the idea behind the configuration inheritance. So, how does it work? We have simply an XML configuration for the full complete system. We have no other configuration except for the logging because we use a module called log4Perl. It's the same thing like log4j from the Apache software project. All other stuff is configured in XML. Here we have a so-called attribute idea, which nothing is else since a simple name for a node to identify a node 100% unique. This makes sense if you have, for example, long lists for extensions or other stuff which should be included in certificates, and you have to identify parts of the configuration. And we have a so-called node super. We only use this node. we only use this name because the attribute was never used by another part of software. And this is the path to the parent. It sounds a little bit difficult, but it's really easy to use. How it looks in practice. In practice, you have a configuration, in this case called the common configuration, and you have a part from the configuration which is called test. And the idea of this part of the configuration is default. So what is present here, it's only a value called myTest. What happens now? Happens now is that we have a very, very deep placed configuration part, and we have even again a part which is called test. You see here, we don't specify any value here. We only specify here a path where I can find the information which usually placed in the tag test. So here you have to go one level up. You have to go into common, you go into test, okay, ID default. It's not really necessary, but we know now if you look for a value which is called deep test value, then the software know, okay, I have to take this value. The important thing is that you can mix the stuff. For example, you can include here another part of the tag test which is called, for example, second value. And you can fill in a value which is called second value and the full name, then the second value is detected and used, even if here's a reference, so you can mix this stuff. This is a little bit useful if you work with extensions and only parts of the extensions change. For example, if you want that the subject item is a part which usually should be entered by the user, but for example the DNS name or an authoritative email address should be constant, then you can mix the stuff here. This is very useful in migration environments. And we have a second way how you can use it. You can also use absolute paths. So you can start here from top, go into common, go into test. And here you see we have no default value here. Because really simple, we have only one value test, so it's 100% unique. Okay, let's move to the last stuff. We don't want to start with too much negative impressions about PKI. But what is the most common problem with Trust Center software? If this is perhaps too negative, okay, we can start with another word. We have very, very cool demo systems, but we have problems usually. What are these problems? Problems usually occurs if you start to look for customizations. Because nearly all systems on the market look for, or even OpenCA, the old system, expect a special workflow. They think they have an RA, they have perhaps a batch operation, they have some approval operations, but if you start to need customizations, perhaps you have another approval way, you have two approval ways, it's okay. Then you got into trouble, because you have to modify the workflow, and the workflow is usually hard-coded, even in batch systems. The other thing is that the most companies, organizations, even if you want to work with students, you have large databases where all identities are known, and you don't start from scratch. Usually you have a big personalization database, and you only want to adopt this database without too much work. So, and the easiest way is if you have a presentation from a Trust Center vendor and then you sit down, the bosses looks very pleasant, and after a while they simply, okay, my business process is the following, simply integrates them. And usually these operations fail. So, the simple conclusion is the horse begins if we start with customization. So what we can do, like all big systems which are developed today, we have a server. This is no surprise. Like the most other servers, we have a context. In this context, we have the XML configuration. This is the part which works with the inheritance. We have DBI. Perhaps you have to notice we use in the complete software stack Perl. We have some low-level stuff which is implemented in C, but the most stuff is implemented in Perl. So DBI is the database interface, which is a little bit modified, but it's the standard interface. We have some session handling, and we have a crypto abstraction. So nothing difficult. Additionally, like the most systems, we have a server API. And the server's API makes no sense without clients. Now, we have a workflow API, and now the thing will be interesting. Here we have the so-called workflow module. The workflow module is a standard CPAN module. You simply can download this on CPAN, which is highly configurable. It's not standard compliant with VFPDC or something. It has an own configuration. The advantage is that it's a very simple configuration. And the advantage for us is that this is all hard code, what you see here. So you cannot change the server API, you cannot change the workflow, you cannot change the modules, you cannot change the context. So it looks a little bit static. The interesting stuff is here for PKI systems that all the other stuff, so this means conditions, validators, activities, and even the configuration for the workflow system is configurable. If you roll out an OpenX PKI systems or you simply download it, then you get a default configuration. This means we have a personal idea how you should manage a PKI. This means you have a database, you have, okay, here a database interface, you have some tables, and we have an idea how you should handle requests or how you should generate requests. But if your expectations does not match our idea, then you can change the complete workflow. In this case, I think, I don't know how many workflows we rolled. I think we rolled out 6 different workflows, and perhaps in the future 7 or 8. The simple thing is that it's only a pattern for everybody. So we don't know what SAP has for a database in R3 or what Oracle has for databases in their human resource systems. We can only say, okay, we support ELAP, we support some databases, and we simply use it. But of course, you can create your own workflows. I think you will say something about it. Okay, how does this design help you? I don't know it, but Alex will give you some overviews about it.
Mic working? Yeah. Okay. Hi at first, I'm Alex. While my Mac is still doing stuff here, I might as well introduce myself. I graduated in mathematics recently, and I work for Synops, which is a small. Yeah. I work for Synops, which is a small network security engineering. That was too close. Better. Okay. Better now. Okay. So I work for Synops, which is a small network security engineering company near Frankfurt. Yeah, we are one of the core developers of OpenX PKI. And one of our customers is a large financial institution who will be deploying OpenX PKI in February, or end of January actually. There we go. That's the end. Sorry. Okay, so what I am going to talk about is a bit more practical than all the theoretical stuff Micha was talking about. I'm going to show you a bit more about workflows with the example of the certificate request workflow, which is one of the standard workflows which we already ship. Then I'm going to talk about a bit about SCEP, which is the Simple Certificate Enrollment Protocol, which is a protocol which you can use for routers, for example, that they get their certificates automatically. Then I'm going to talk a bit about smart card personalization, which is one of the nifty features we recently built in. Yeah, I'm going to talk a bit about support, how you can get that. And of course, we always want to make a bit of, we always want to have some new developers, and if we are lucky, somebody might get interested in helping us out. So there's a bit of hackers wanted as well. Okay, so there we go. Certificate requests. First of all, I don't know how many people of you are familiar with CA systems, so I'm going to show to you how it looks from a user perspective first, and then I'm going to delve right into the details of how the workflow actually looks like. Okay, so the user basically uses the web interface. There's one of the clients that Micha was talking about. So basically the web interface implements a web client that talks to our server. And the user can actually do either a browser-based request, so if he's using a Mozilla-based browser or Opera, for example, then he can do this using SPK-C, or if he's stuck with IE, he can use the XML ActiveX control, which comes with every Microsoft Windows system. Well, if you're keen to, you can also, of course, upload your own PKCS10 file, which is for the more exotic cases, I guess. Or if you can't do either, there's always the possibility of doing the key generation